Hello and welcome to all. My name is Stephanie, and today we're going to discuss exponents with an emphasis on evaluating powers. So let's get started. So we're going to begin today's discussion by talking about some important definitions. So today we're going to be dealing with bases and exponents. So in order for us to understand, it's better to see it so that we can kind of have a working definition of it. So a base is going to be literally the big number, our base to our power. So this is the base, and we're going to have an exponent at the top. So this is the base. 2 is the base. Okay? And let me give you another example. So if we were to have a variable as our base, it would be something like a, and our exponent would be 8. So I'm actually going to color code these so that you can see which one is the base and which one is the exponent. So I'm going to put our bases as red, like a burgundy color. So our base is going to be, let's say 2, and then our base here is going to be 8. So this is our base, and our exponents are the numbers. So I'm going to use 2, and the exponent is the smaller number, so I'm going to use blue for that. So let's say 2 squared, a to the 4th. Okay, so let me just give you some more examples. So I have b, this would be our base right here. And let's say we have 4, b to the 4th, so the 4 would be our exponent. Okay, so these two things, the base and the exponent, all of this is called a power. So this is called a power. Okay. And what do these powers tell us? Well, they tell us the number of times that we multiply the base as a factor. So I have an example here at the bottom. We have 2 to the 4th. So our base is 2 and our exponent is 4. So this power is going to tell us how many times to multiply 2. So here it's a 4, so we're going to multiply 2 4 times. 2 times 2 times 2 times 2. And this will give us 16. Okay, so let's go ahead and do some problems. Okay, so we have this exponential form on the left, and we have in the middle, we have this column that asks us to, again, write our exponential form into words that we can understand. And on the right, we're going to write what it means, okay? So for the first problem, 4 to the 5th, we're literally going to write that, 4 to the 5th power. Okay, and what does this mean? It means 4 5 times. 1, 2, 3, 4, 5. Okay. Our second problem, exponential form example, is going to be 2 squared. So we're going to write 2, you can say 2 squared, or 2 to the 2nd power. Okay, so it means, what does this mean? 2 times 2. And now finally we have y to the 8th. So we say y to the 8th power. And what does this mean? It means we're going to multiply y, 8 factors of y. 4, 5, 6, 7, 1, 2, 3, 5, 6, 7, 8. Okay? So let's go on to our next example. So we're going to write the expression in exponential form. Okay, so we're going to basically translate this from words into mathematical notation. So we have 5 squared. So we're going to write 5 as our base, and squared means 2. So that would actually be a good thing. Squared is going to mean 2, and then cubed is going to mean 3. Okay, so moving on to our next example, x to the third power. So I know x is going to be my base, and to the third power tells me that we're going to have a 3. So I'm going to write 3, x to the third power. Now for our final example, we have y cubed. So y is going to be our base, and cubed we said was 3, so I'm going to write 3. So it's 5 squared, x cubed, and y cubed. Okay, so let's go on to the next problem. So here's a math tip. Math is a language. You know, we want to know what we're trying to do, what we're saying, what we're explaining on paper, and have someone read it and also understand it. And for example, x to the 1 will be written as x without the 1, without the exponent. And it means the same thing. And it is just a matter of being able to recognize it. But you've seen something like this before when we discussed fractions. Let me write it better. So x, I don't know if you remember, but when we discussed fractions, let's go kind of to an aside here. When we have fractions, we also have this imaginary one when we have whole numbers. So when we have like 2, this can be rewritten as 2 over 1. It means the same thing. Just like here, we have x to the first power, but we don't write it. So let's go ahead and do some more problems. So now we're going to evaluate. We're going to evaluate x squared when x is equal to 2. So as you notice, all of these concepts build off one another. So we're going to substitute x equal to when we have x squared. Okay, so our first step is to substitute. So I'm going to write 2 squared. And you can write out the factors. So we're going to write 2 times 2. Our base is 2, and we are going to multiply it 2 times, 2 factors of 2. So now we multiply, and that will give us 4. Okay? Let's try another example. Evaluate the variable expression when x is equal to 2 and y is equal to 3 for the following. So x squared plus y cubed. So our first step is to substitute. So x is equal to 2, so it's going to be 2 squared plus y is going to be 3, so you write 3 squared. So we're going to write out our factors if you want. So 2 times 2 plus 3 times 3. Now we're going to multiply, so this would be 4 plus 9. And now we add, so it's going to be 13. Okay? So we're going to do another problem. So we're going to evaluate the variable expression when x is equal to 2 and y is equal to 3 for the quantity x plus y squared. So we're going to substitute, and here's very important that we pay attention to our parentheses. So we're going to substitute, we're going to have 2 plus 3, all of this squared. So here I'm going to actually simplify this even more. So I'm going to put 5. 2 plus 3 is 5, so it's 2 squared. And now I can write out the factors. So it's going to be 5 times 5. We multiply, and this will be 25. Actually didn't need this step here. Okay, so this is our answer, 25. Simple enough. Let's try another one. Evaluate the variable expression when s is equal to 2 and t is equal to 3 for the following. So again, we're going to substitute. So we said t is equal to 3 and s is equal to 2. And all of this is squared. Sorry. So this is going to be squared. Okay, so I'm going to do what's in, I'm going to do the subtraction inside of the parentheses. So this will just be 1 squared. You can write out your factors, 1 times 1. There's 2 factors of 1, so 1 times 1 is 1. Okay, so that is your answer for that one. Let's go ahead and go to the next problem. Evaluate the variable expression when s is equal to 2 and t is equal to 3. So again, we're going to substitute. S is going to be 2, so it's going to be 2 squared minus t squared is going to be 3 squared because we said t is equal to 3. Now, I am going to write out my factors for this one. So it's going to be 2 times 2 minus 3 times 3. And let me actually write that a little bit higher so that we know that we're multiplying and that it isn't a decimal. So 2 times 2 is going to give us 4 minus 3 times 3 is going to give us 9. And if we add 4 minus 9, if you've learned the keep, add, opposite, so we're going to keep this number the same. We're going to add, and we're going to make this into the opposite, okay? So 4 plus negative 9 is going to give us negative 5. Okay? If you have any questions about this method, it's called keep, add, opposite. Okay, so we're going to keep the number in front the same. We're going to add, so we're going to add instead. So if we have something like this, we're going to add instead, and then we're going to make this number into the opposite. Okay, if you have any questions about that, I'll be happy to explain it to you. But for now, let's go ahead and go to our next problem. So we're going to evaluate the variable expression when s is equal to 2 and t is equal to 3 for this following expression. So we're going to, again, substitute our value. So t is 3, according to our problem, plus 2, which is s, and all of this is going to be squared. So I'm going to add whatever's in the parentheses first. So that's going to be 5. 3 plus 2 is 5. And we're going to square this. So it's going to be 5 times 5, which is 25. And that's our answer for this. I hope that you're getting a lot of practice in. If you have any questions, you can always leave them in the comments and I'll be sure to answer them. So moving on to our next example, we have t squared minus s, and we are asked to evaluate for the given values. So s is equal to 2 and t is equal to 3. So I have here t squared, so I'm going to write 3 and I'm going to square it, minus s, and we said s was 2. Now I'm going to evaluate this power. So this is going to be 3 times 3. And 3 times 3 is 9. Minus 2. 9 minus 2 is 7. So that is our result for this. Let's see if we have any more. We do. We're going to evaluate this variable expression when s is equal to 2 and t is equal to 3. So again, we're going to substitute. We said s was 2, so I'm going to write 2 squared minus, and we said t is 3, so I'm going to write 3. Now I'm going to evaluate this power, so I'm going to write 2 times 2 minus 3, and this is going to give us 2 times 2 is 4, minus 3, and that will give us 1. Okay. Exciting stuff, I know. But for now, that will be all. Thank you so much for your time and attention. I really do appreciate it. Next time, we will continue our discussion on exponents with an emphasis on grouping symbols and volume. So for now, thank you so much for watching, and we will see each other next time. I hope you have a good rest of your day.